you have seen inequalities before, we've written inequalities. We did our Unit 1. We wrote inequalities and we solved them. You have also written a ton of equations in standard form. You've written a ton of equations in slope-intercept form. You graphed those things. So today should not be too crazy. We're just learning the main thing we're learning how to do is graph linear inequalities, which you have not necessarily learned how to do yet. Okay, so linear inequalities, you know what this looks like. You got x and y, typically 2 variables. And you have your inequality sign. Let's see. A solution of an inequality is an ordered pair, x comma y. Let's add that so we don't forget what an ordered pair is. That makes the inequality true. So I could plug in a value for x and a value for y. That would make the inequality make sense. Okay. A linear inequality in 2 variables has an infinite number of solutions because there are lots and lots and lots and lots of things that work. This will make more sense. So let's first look at which ordered pair is not a solution of negative 2x plus 3y is greater than 8. So what we would do is take those ordered pairs and plug them in. I'm going to show my work for the first one. So what's my equation? I need to write that down. So it's negative 2. What's my x? Negative 2 plus 3y. So plus 3 times 1 is greater than 8. Maybe. Okay, so it's 4 plus 3. So 7 is greater than 8. Is that true? No. Certainly not. So lucky for us, the first one is the one that's not a solution. So you don't have to go through the rest. So we're assuming the rest are true. If you want to check it, you could. I could plug in negative 1 for x and 4 for y for the second one, see if that works. Does it work? 2 plus 12, 14 is greater than 8. Yep, there you go. Linear inequalities on a graph. I really like these. There's lots of words here. All points on one side of the boundary line are solutions, while all points on the other side are not solutions. So you have this first one, y is greater than 3/2 x minus 1. It's saying only the y values that are greater than that line make this inequality true. It's greater than. Do you notice what's a little bit different about this graph? Emma, what's different about it?
Is it the line that's dashed?
Yeah, it's dashed. Why do you think it's dashed? Bella, why do you think it's dashed?
Because it's greater than or less than.
Right, it's greater than. It's not or equal to. So what we're saying is the stuff that's actually on the line, the points that are on the line, do not work. This is like that open and closed circle thing. It's like the same thing. We're saying you either include the points on the line or you don't. Since it's greater than, and it's not or equal to, we can't include the points on the line. So each point on the dashed line is not a solution. A dashed line is used for inequalities with greater than or less than. That's what it says right there. Good. So this one is a little bit different. It's the same equation, right? Oh, close. The inequality is different. It's saying y is less than or equal to negative 3/2 x plus 1. You would graph slope-intercept like normal, but because it's or equal to, we have a solid line. And then, do you notice which way it's shaded? Shaded down, right? It says y values less than or equal to. Y values are less than going down on a graph. So we shade the part that's down. So we're going to graph this one. Negative 1/2 x plus 4. The first thing I would always do is just get your points. Graph your points like normal. So I have a starting point of 4, right? Would someone in slope dude language tell me negative 1/2, what's slope dude? Actually, tell your neighbor, what's slope dude doing? Is he going up or down? What? Down how many? 4. 1. Okay, and then Nancy, where does he go after that? Yeah, so I'm going to say right. Okay, let's go. We're going to graph our intercept, and then we're going to go down 1, right 2. Keep plotting points like we've done before until we run out of room, and then we reverse it. It's a really big intercept.
Why is it so big?
I don't know.
Why is it so strange?
You're doing it wrong. You're going right.
What did I do wrong?
You're going right 4.
Okay, connect your dots. Oh wait, should we have a solid or a dashed line? Dashed, because it's less than. So it's a dashed line because it's less than. Okay, this is the part where I see a lot of students make mistakes. We need to read this. It says, when you're shading, it should be y values less than negative 1/2 x plus 4. So what it's saying is y has to be less than the line. If you think about y values, so it's got to be less than, which way do I get less y values that are smaller than the line? Up or down? Y values are always up or down? Point. Right, y values get smaller going down, and so what we do is we shade this in. Ooh, I'm going to use a highlighter. That'll be fun. Oh, it didn't work out like I wanted to. Whatever. I'm shading everything below that line. Graph, it's either going to be a horizontal or vertical line. Do that now. Or vertical.
Horizontal.
How do you know?
Because y is less than.
Okay. Do you remember that acronym we talked about last week? Hoivux. Horizontal lines have a slope of 0 and are y equals. So I know it's not an equal sign, but it still works the same way. So we're going to have a line at 2. I'm not going to plot it just yet because I don't know if it should be dashed or solid. Sarah, should it be dashed or solid? It should be dashed because it's less than. It is not or equal to. So we draw a dashed line through 2 with arrows. It does not have a restricted domain. And then we need to shade. It's saying y values less than my line. Read it from left to right. So should I shade up or down? Point. Very good. Yep, shade down. So this part. Here. So this part is good. This part up here, bad. Doesn't work, does work. Remember, you need to divide, you need to divide both terms by 2. Did we divide by negative? No, so don't flip the sign. But you do need to simplify. So you should end up with y is greater than or equal to 4 minus 2x. So your intercept would be 4. You're going, so it's negative 2 over 1. You're going down 2, right 1. That one worked out nicely for us. Go ahead and plot your points. Let's say that. Plot your points. It's scaled by 1, so that's nice. Down to right 1. And it should be a nice negative line. Okay, class, is this going to be a solid or a dashed line? Solid. Yep, solid. Don't forget your arrows because it goes to infinity and beyond. All right, this is where things get a little tricky because right now it looks less like up or down and a lot more like left or right. So we're still dealing with our y's because this equation still has a y in it. So I'm still saying it has to be y values greater than or equal to my line. So what I would do is go to my y-intercept and say from my y-intercept, I'm either going to shade the area that's above it or the area that's below it. It's y values greater than or equal to my line. So should I go from my y-intercept, should I go up or down? Point. I'm going up because it's greater than, which means I'm shading the area up here, which keeps going and going and going all the way down. So you have to shade this entire area.
Okay.
So decide from your y-intercept which direction to go. If you want to make a note of that, there you go.